All right, we're going to go through this pretty quickly. If you miss something, you can go back and slow down. Arc AB. So we look over here. AB. Okay, that is not even close to half the circle. That must be a minor arc. Also, it's an arc that's labeled with 2 letters rather than 3. Major arc is usually labeled with 3 letters. Angle COB. COB, that's this angle right here. That is the central angle. It's an angle coming from the center. Line OC. Hey, from the center to the edge, radius. Angle ADB. That angle, its vertex is on the edge of the circle. It's on the inside of the circle. That is called an inscribed angle. EA, line EA, that is touching the circle in exactly 1 point. That's called a tangent line. DB. Hey, it goes through the center. A chord that goes through the center is called the diameter. What is DA? Just a chord. Arc DCB. It's an arc that's written with 3 letters, so it's a major arc. What is the relationship between ABD and the measure of arc AD? Angle ABD is inscribed. Let's see if I can focus this better. Okay, so ABD is inscribed, and see how the A and the D surround the B, ABD. Arc AD is called the intercepted arc. Okay, the inscribed angle is always half the measure of the intercepted arc. This could also be written as 2 times angle ABD is equal to the measure of AD, arc AD. What is the relationship between AOD and the measure of AD? AOD is the central angle that intercepts the exact same arc, AOD. So surrounded by A and D, again, intercepts the same arc, but the central angle is congruent to its intercepted arc measure. Angle AOD is congruent to measure of arc AD. What is the relationship between OA and the tangent line? And they already have that shown here with this right angle. OA is perpendicular to line, I guess we'll just call it line E. If AOB is 60 degrees and R, the radius is 10, what is the length of AB? AOB. AOB is 60 degrees. And the radius is 10. So this is 10. This is 10. What is the length of AB? All right. The sides are both 10, which means this is an isosceles triangle, which means the base angles are equal. But if the base angles are equal, this is 60 degrees, which means these other two need to add up to 120. 120 divided by 2 is 60. So this is not only this is not isosceles, this is actually equilateral. So this length is also 10. What is the length of AB? 10 units. Moving on, number 2. Find the area of circle Z. So first, I really just want to focus on filling in any missing pieces that I can. Okay, if this is 40 degrees, I look at the angle that is the inscribed angle that has this intercepted arc. Follow the sides all the way to, okay, this is the corresponding inscribed angle. And that measure is half of this measure, so that would be 20 degrees. Now, man, we don't have anything else, but we actually do, because this is a special arc. This arc is being intercepted by a 180-degree angle. Central angle, sorry. This arc is being intercepted by a diameter across. So, if this measure is half of the circle, because VY is a diameter, then the arc measure is half of 360 degrees, which would be 180. Because an entire circle measures to 360 degrees. Awesome. If this is 180 degrees, let's find the angle whose intercepted arc this is. V and Y. So the angle made up, the inscribed angle made up with outer parts V and Y, intercepted arc VY, is the angle, the inscribed angle that comes from X. That has to be half of 180. What's half of 180? 90. That's how we can know and not just assume that this is 90 degrees. It's a guarantee it's 90 degrees because this inscribed angle, its intercepted arc, measures 180 degrees, so it must be half, therefore it's 90 degrees. And then our final piece. Which we may not even need to find, but doesn't hurt to finish it out. Okay, 20 plus 90 is 110, so this should be 70. Intercepted arc would be 140. 180 plus 140 plus 40, yeah, that's 360 total. 90 plus 90, that's 180 as far as the interior angles of a triangle go. All right, so you have a right triangle, you have all of the angles and one of the side lengths. You can definitely find any other missing parts that you may want to find. What do we need to do? Find the area. So yeah, I want to find the diameter, which is the hypotenuse of this right triangle. So I'm going to redraw that triangle. Most of you will be able to probably see it. But if not, that's not a problem at all. This is V, X, Y. This is 70 degrees, this is 20 degrees. I'm going to circle the angle I'm going to work with. I'm going to work with V. This is 9. This is my diameter / hypotenuse. That's what I want to find. So this would be my adjacent side and my hypotenuse. So I'm going to use cosine. Cosine of 20 is equal to 9 over, I'm going to say D because it's the diameter. So 9 over D. So I'm going to multiply both sides by D. And then I have d cosine 20 equals 9. Divide both sides by cosine 20. So d is equal to 9 divided by cosine 20. Divided by cosine 20. That should be 9.6. Which means r, your radius, is half of that. .8. Area. Running out of room here. Area is equal to pi r squared. So I'm going to take 4.8 and square it. And then times it by pi. 72.38. That's barely even a couple tenths off from the answer key. That would definitely be an acceptable answer on the test. Find the length of xy. So not the measure, the actual arc length. Arc length is given to us by theta over 360 times by arc length. Okay, that corresponds with the circumference of the circle. So 2 pi r. Or pi d, since you have the diameter. XY. So the central angle that corresponds is also 40. So this should be 40 over 360 times 4.8 times 2 times pi. .35. And that would be centimeters. And this is not degrees. That I must have confused it with the 180 degrees right next to it. 72.38 centimeters squared.